So good morning all. So today I am going to discuss about a subject by name computer graphics and visualization. So it is there for 6M CSE people in BTU. So coming to the subject, this subject deals with the building of images using a program. Till now what we people have seen is, we people have seen many programs in different programming languages where we are going to deal with the data itself. Like we are going to give input and we are going to get output by processing the data. But we have not got an opportunity to design an image. So in this subject what we are going to do is, we are going to design an object or an image using a programming language. So this subject deals with how we are going to build an image in programming. So when it comes to an image, first what we are going to do is, we need a display device to that one. First, this subject starts with the display devices. So the first display device which was there for us was the CRT, that is cathode ray oscillation tube, was the first display device which was there for us. So after the CRT was implemented or innovated, so next there were different variations in the CRT. So CRT, first it was implemented as a bare one or the black and white one. So next came the concept of color CRT, that is color cathode ray oscillation tube. Next came the LED displays, and now we are in the era of LCD and LED. So that is the first thing what we are going to see in this subject. After we have seen about the display devices, next what we are going to see is, we are going to see something about creation of an object. So if we see, for any of the object creation, the base is the vertex, or we can say it as a point. So point is the base. So from the point only we build other parts of the images. So first what we are going to see in the first module in this subject is, we are going to see about the display devices. Later on we are going to see how a vertex can be created, and after a vertex has been created, next we are going to see about the attributes, or what are the things we can do on a vertex. The basic thing what we can do on a vertex is, we can increase the size of the vertex. After we have increased the size of the vertex, next what we can do is, next option what we will be having is, we will be having an option of coloring it. So those are the two attributes what we can add to the vertex. So after a vertex has been done, next what we will be doing is, we will be creating a line. That will be the next step what we are going to do. So for the line also, what we need to do is, we need to have a basic idea, like a line is nothing but it's a combination of vertices only. To draw a line, what we need is, we need two end vertices. We need two end vertices. After we build two end vertices, we can join that with a line. So basically we will be starting with how to create a vertex and how to create a line. And next what we are going to do is, we are going to use the attributes to that one. Which are the attributes what we can do? The attributes what we know is, we know how to increase the size of the vertex or a line. Next we can color that one. So those are the two things what we are going to do in the first module with the display devices. After that we are going to see what are the applications of computer graphics. Now the applications of computer graphics are vast, like there is no area where we are not using computer graphics actually. Rather than saying the areas where we are using computer graphics, there is no area where computer graphics is not being used. Like the applications are gaming, 3D movies, that we can say it as entertainment, animation, even for the education purpose we are using, and the CAD and CAM what we are using for designing, we can do that using the computer graphics. So these are the things what we are going to see in the first module. So with this what we are going to do is, we are having some algorithms to draw a vertex, to draw a line, and to draw a circle. So first what we are having is, we are having one algorithm by name digital differential analyzer algorithm. Digital differential analyzer algorithm. So that is used to draw a line. Next what we are going to do is, we are going to use one more algorithm by name resonance algorithm. So even that is being used to draw a circle and as well as a line. So these are the things what we are going to see in the first module. Coming to the second module, next what we are going to do is, we are going to use the polygons. A polygon is nothing but it's a closed surface with more than 3 vertices. So the triangle is the minimum polygon what we are going to use, and the square, rectangle, or the various polygons what we are going to use. So next in the second module what we are going to see is, we are going to see how a polygon can be built. And next, once the polygon or any geometric object is being created, next what we need is, we need transformations. We need transformations. So the transformations are nothing but, our translation is one transformation, rotation is the other transformation, and scaling is the other transformation what we are having. So rotation, what we are going to do is we are going to rotate the geometric object in the clockwise direction or the anti-clockwise direction. There we are going to give the angle as the input. Next what we are going to do is we are going to translate the geometric object. Means translation means what we are going to do is we are going to move the geometric object from one position to the next position. Next is scaling. In scaling what we are going to do is we are going to increase the size of the object or decrease the size of the object. These are the things what we are going to see in the second module. So coming to the third module, we are going to see how a image, if it is being generated, how we are going to fit that into the screen. So for that what we need is we need clipping. We need clipping, inline clipping. There are three things. First one is a point clipping, second one is a line clipping, third one is a polygon clipping. So for these three things we are having three different algorithms by name Cohen Sutherland, Hodgman. Algorithms are there for us to do this task. And in the third module we are going to see something about color also. As we know that there are three basic colors, RGB, red, green and blue are the three basic colors what we are having, and with these three basic colors what we can do is we can derive three different colors, can, magenta and yellow. We will be seeing those things. Next, coming to the fourth module, we are going to see about the projection, like how a geometric object can be projected. So there the first projection what we are going to see is we are going to see about a parallel projection. And in second thing what we are going to see is we are going to see about the perspective projection. Parallel projection means the geometric object will be parallel to our view plane. Parallel to our view plane means we will be seeing only one side of the image. For that we won't be giving the realistic images. So next thing is our perspective projection. The perspective projection best example is our eye. In eye or the camera whatever we see, they are going to meet at a point called as convergence point. All the views are going to meet at one point, that is called as convergence point. So that is nothing but your perspective projection, and with this parallel projection and perspective projection we are going to see something called as 2D pipeline and a 3D pipeline. So building a geometric object is not a single step process. It is a series of steps what we people are going to do to build a geometric object. The first step what we are going to do is we are going to decide upon, let us take a realistic example where I am using my camera. I need to decide upon first what to capture. If I am on a holiday or if anywhere I am going, first what we are going to do is we are going to decide upon what to capture. That is nothing but our world coordinates. Once I have decided upon what to capture, next what I am going to do is I am going to decide upon from where to capture, which angle. So first what we are going to do is what to capture, second what we are going to do is we are going to decide upon where to capture, and third what we are going to do is we are going to decide upon the normalizing those values. After I have decided upon what to decide and what to capture and from where to capture, next what I need to do is I need to normalize those values which I have captured. After that what I need to do is I need to convert those coordinates into device coordinates. So these are the things what we are going to see in the fourth module. So coming to the fifth module, here what we are going to see is we are going to see the basic input devices what we are having. So input devices are broadly classified into physical input devices. The second one is logical input devices. In the physical input devices, we have the traditional input devices like the keyboard, mouse, joystick, light pen, scanner, voice. Everything is the input device what we are having. So what we have not came across is we have not came across something about the logical devices. So the logical devices are the programming languages whatever you use. So if you take the basic example of a C program, in C program input can be given by scanf. Output is got by printf. So here what happens is scanf is also one of the input device. So that is nothing but our logical input. So that is nothing but our physical input and logical input. Next what we have is we have something called as a measure of a device and trigger of a device. So what happens is we are using the input devices, right? The keyboard or mouse or anything. Once we press the button, the input won't be given. Once we press the button and release that one, the input is given. It's actually a two-step process. One is what we are giving to the device, input device. Next is what the input device returns to the computer. Okay, trigger is what we give to the system and measure is what the input system gives to the computer. So this is nothing but our measure of a device and trigger of a device. And in this what we are going to do is we are going to discuss, even we are going to come across like it is not the only window what we are going to create. What we can do is we can create sub windows also. For our application, for the display process, what we can do is we can create sub windows. That is also we are going to discuss here. And after that what we are going to do is we are going to discuss something about menus and picking. We are going to discuss about menus and picking, and after that what we are going to do is we are going to discuss something about curves. So how a curve can be drawn using computer graphics. So in this subject overall we are going to see all these topics. So at the end of the subject, what you people, if you are interested, really interested, what you people can achieve is, you people will be in a situation of creating some basic objects, like creating a human being or a car or a bus or a aeroplane or a jet or a train, and you can give movement to that one. So in engineering, if you want to create any object, this is the only subject which is there for you people, where you can create an object and you can give movement to that one. So these are the things at the end of the semester or at the end of this course, after you learn successfully, you people will be in a situation to design your own objects. And for this, there is one more mini project is there with the lab. So this is what you people can learn from this subject. Okay, thank you.